Welcome everyone to this ASCETiC project webinar. Just a quick introduction. My name is Karim Jamam. I'm from the School of Computing, University of Leeds, and I'm the scientific and technical manager of this project. And before we start, I would like to hand over to Anna.
Yes, just to let you know that this is the first of our series of webinars in which we are presenting our work in the ASCETiC project. ASCETiC deals with the optimization of energy efficiency in cloud computing, and we will be doing this in introductory webinar to our concepts and our architecture, and this is going to be followed with the more technical webinars during this week and also until the end of the month. You can use at any time the chat to make your questions. We will respond all of them at the end, as we have a specific slot for this. And with regards to the session now, Karim will be presenting all the ASCETiC concept and technical architecture for the project, while I will be dealing with the more business-oriented aspects on the second part of the webinar. So please, Karim, go ahead.
Excellent. Okay, yeah. So here we are. As Anna said, this is very much an overview of what ASCETiC is all about. I will probably just set the context of this. It's nothing to do with Star Wars, but something to do with certainly clouds, which probably in many years ago will be referred to as a long time ago in a galaxy far, far away. There was actually cloud computing, and cloud have been very much attracted the attention in terms of their role in having a clear computation shift from the client to the provider, and they made actually distributed systems, internet scale, a reality, thanks to this cloud data centers, which we are very much seen as computing power plants. But these computing power plants will certainly require high levels of performance, reliability, and certainly efficiency. So when over the last probably I would say probably 8-10 years, and everyone was really enjoying cloud computing benefits, especially from their advance in around 2008. And they are all they provide a service orientation. They are elastic. They are dynamic. There's an economy of scale that have certainly that we have certainly seen over many years. They are market oriented. They are autonomic, sorry, and they make use of virtualized infrastructures. Thanks to all these benefits, we have also seen a large families of applications taking advantage of cloud computing. An example from the science and also from the consumer and social aspects. The likes of Amazon, Twitter, Facebook, Google, etc. would rely on this on cloud computing to provide us with their services, and us as consumers could potentially deploy our own applications to actually run on the cloud. A good example of this could be a consumer relation management application. It could be an e-commerce application, an accounting application, and the like, from really the business perspective. There is somehow a dark side of this, is that many reports over the last few years have basically looked at the total global electricity that data centers and cloud data centers actually consume, which is about 2% of the total global electricity worldwide. And then these data centers are viewed as major contributors to the world's total CO2 emissions. And therefore, there is certainly a problem in terms of the power and the energy they consume, and the negative effects these could actually have on the overall environment. The other alarming things is that there is a clear trend in power consumption used by data centers, which is and will still be on the rise. Which means that if nothing is being done at the moment, then the problem can simply worsen. So, ASCETiC, as an EU project funded under FP7, is basically looking at how we could contribute to potentially having clouds to operate in a more energy efficient way. That's as simple as that. The way the ASCETiC is tackling this problem and certainly trying to contribute to one solution to this problem is basically to look at a cloud architecture, a typical cloud architecture, and say, can we identify the missing functionalities in any cloud architecture to support energy efficiency across cloud layers, which means that ASCETiC approach is to say that if you take a cloud architecture, a layered cloud architecture, there are certainly issues and here and there. There are solutions here and there, but can we have an overall view to tackle this energy efficiency problem? And by doing that, ASCETiC is proposing to define and integrate explicit measures of energy and the energy requirements in the design and development process for the software to run on clouds while keeping quality of service at an acceptable level. Which means that ASCETiC aim is to look at energy efficiency support from the time you design your software, you implement it, you operate it, you run it, and basically you ensure that by doing the whole process, you are again supporting energy efficiency in all those stages. So the way they're going to do it is basically to provide a reference architecture, which is again energy efficiency aware, and to propose an implementation of this architecture. And by demonstrating this, ASCETiC looks at two use cases. One is from a company called Green Prefab, which actually specializes in green building design. This company runs millions and millions of simulations on the cloud with hundreds of parameters, and these application will be seen as an interesting one to again demonstrate that some actually gains in energy efficiency that ASCETiC is proposing. And the second one, ATC, is a multimedia cross-channel solution, very much to do with a flow of news from all around the world, where this data needs actually to be managed at large scale, and therefore ASCETiC would also propose this energy-aware reference architecture to show the benefit of having such applications. Again, benefit from the actual architecture. So the consortium itself is formed by 9 members. There are again a bunch of academic and industrial partners. The project is led by Atos Barcelona. Right. Hang on. Objectives. Clearly, it's about models to develop for software design that support energy efficiency from the time software is actually designed, then developed, then run. It's also about developing and evaluating an overall framework where we can clearly identify the energy efficiency parameters and metrics to actually measure how well this architecture and these components with this architecture are actually doing. The third one is about methods to measure, analyze, and evaluate energy use in software. This is again from the time you develop software until you execute it. And finally, how we can integrate energy efficiency into the overall stages of the service lifecycle from the time we construct it, deploy it, and operate it. And by doing that, we can see a loop in the overall cloud architecture, as you will see later on, where we can basically learn from the decision we have taken at the design of the software until we actually operate it. And therefore, this learning loop will somehow lead to what we call an energy efficiency embedded software lifecycle. Now, we are doing this because we can certainly see main actors and stakeholders benefiting from this project, but at the same time, these actors and stakeholders facing a number of problems. So these stakeholders, main actors, are basically these ones here. These are, we can see a software designer, a software developer, a service deployer from the business perspective, trying to take a service and deploy it on the most energy efficient infrastructure. We can see a service deployer from the technical perspective, and then we can see an infrastructure manager that somehow operates the cloud infrastructure with thousands and thousands of physical hosts. So we can look back at the solutions that we have that are found in the literature in terms of energy-aware computing. These solutions are actually have actually been in place for a number of years, and the literature is certainly rich in terms of research solutions. So we could look at hardware and potentially say, can we support energy efficiency thanks to DVS, dynamic voltage and frequency scaling, or have energy efficient compilers? We could look at the virtualization aspect of the machine and say, can we have hypervisors such as Zen or KVM that is somehow energy aware? We could look at energy efficient network protocols, knowing that the network itself is power hungry. We look at data centers and say, can we look at scheduling policies that potentially can turn off idle servers or consolidate virtual machines to save energy? So with this performance and energy focus in mind, with this cost reduction in mind, this improved use of resources, environmental impact in mind, we can take bits and pieces here and there and potentially combine them in a coherent, using a coherent approach. We could potentially look at energy efficiency software and its engineering, which is again something that ASCETiC has looked at and brought into this overall arena of energy efficiency in cloud, because again, the approach of ASCETiC is to embed energy efficiency at the software engineering side. Okay? And then from there, look at other layers within the cloud architecture that could support energy efficiency. Back to our stakeholders and actors, there are certainly targeted solutions. They could be partial solutions. They could be targeting specific problems, but they're not always efficient if they are actually used in isolation. So at the moment, we can take all those stakeholders and give them one targeted solution, a little piece of a cake. But ASCETiC is saying, well, can't we again use a different approach where we take an overall coherent and collaborative approach between the layers in the cloud stack and to support energy efficiency from the time again we design software till the time we actually run it on an infrastructure. So what would ASCETiC as looked at is again coming up with a radical approach from the requirements gathering to the operation of an actual service on a cloud, and again to do this, there is certainly a need for a new architecture. This is what, again, some of the requirements from the stakeholders. I will take an example for each one. From the software designer perspective, how can I combine energy awareness with the principles of requirements engineering and design modeling? Can I actually specify my energy goals and requirements to evaluate how much energy my application is likely to consume? From the software developer, well, I write software. Can I be empowered to produce energy efficient code using a specific programming model? Can I potentially use annotations to inject probes in my code in order to take specific energy measurements? From the service deployer business perspective, can I have energy profiles for my application? Because again, I'll be very much interested in knowing how likely my application is going to consume energy before it's actually deployed. And therefore, can I identify workload profile on the infrastructure where my application is going to run? And by the way, what are the energy models on these virtualized infrastructures? From the service deployer technical perspective, is certainly, again, how can I deploy my application and my service in an energy efficient environment? From the infrastructure manager, a lot has been certainly done in that aspect from in the literature and in current cloud solutions. It's very much about how do you manage your services, your virtual machines, your physical hosts in an energy efficient environment. How can you schedule, manage your virtual machines efficiently? How can you monitor energy consumption and certainly adapt accordingly? Taking an example of cloud architecture as we understand it today, we have the user level and the system level from the top, using a top-down approach. Right in the middle, we have the middleware. We have the cloud programming with its environments and tools. We have the core middleware that looks at how you can manage your application, and certainly the virtualization layer that sits between the application management and the cloud resources. So what ASCETiC is basically looking at, or the approach it has taken to support energy efficiency at this stage, is to say, well, we can see actually three dimensions to do this. The first one is what we call energy awareness across all layers. So you take any of these layers, you expect to have a component or a set of components within each layer that are energy aware. And these components will not only understand what energy awareness is about, but would actually work together with other components in the same layer or in other layers to ensure that your service operates in the most energy efficient way. So energy efficiency again spans then across all layers from the cloud application to the actual system level. What ASCETiC is actually doing is to say, well, if we need these layers to operate in an energy efficient way, these layers will need to talk to each other. They will therefore need to adapt to specific requirements in terms of energy, in order again to ensure that the application runs in the most energy efficient way. There are certainly other aspects that we, in terms of quality of service, that these components would need also to support. For example, cost or even, or more importantly, performance of the application. And therefore, you could see here certainly some trade-offs when it comes to this adaptive management that will need to look at these three parameters: energy, cost, and performance. The second dimension is the cloud service lifecycle. If by deploying a service to run on this architecture, you will need to construct it, you will need to deploy it, you will need to operate it, and by doing that in an energy efficient cloud architecture, you will need to evaluate how good, how well you actually have done in terms of the decisions you have taken at the time you design your software until you actually run it. And what's interesting here is that in each step of the service lifecycle, you will need certainly key performance indicators to tell you again, to measure how well you have operated your actual service. And you could also expect some service level agreement be in place between the layers in the cloud stack, so that again each layer becomes itself a server of the layer above it, and certainly a customer of the server below it. The third dimension that ASCETiC has taken is to do with the models, the most well-known models and most well certainly deployed models in the real world: the software as a service, the platform as a service, and the infrastructure as a service. Therefore, you will expect that ASCETiC will be able to propose a set of tools that would basically be used using either of these three models: software, platform, and infrastructure. So, by doing that, here are the ASCETiC dimensions: cloud models, SaaS, PaaS, and IaaS, service lifecycle, construct, deploy, and operate, and finally an approach to a layered cloud stack from the software design to the system level, bringing the middleware into place. And again, you could see how somehow complex the supporting energy efficiency across all these layers can actually be, because you will need again to identify the missing functionalities here and there to make that happen. So, what would be the actual outcomes if we take layered architecture, we take the three models, we looked at the service construction, deployment, and operation as part of the service lifecycle? Well, what ASCETiC is main outcomes are basically a toolbox, which you could see here on the top right of the slide. And this toolbox, well, in the toolbox you will find a set of tools. And what are how do these tools look like? Well, ASCETiC is proposing an energy-aware software design and programming IE, as an integrated environment. Again, these are very much for software engineers and software developers. It's proposing a service energy measurement and modeling tools. Again, this is to do with how much energy my application is likely to consume before it actually operates on a cloud infrastructure, and is it possible, and how much my application was deployed is actually consuming energy. We could look at the quality of service energy aware framework. Again, this is to do with a framework that says consider energy and cost and performance. How am I going to actually optimize all these three in order again to operate my service on a cloud infrastructure? Energy-aware service deployment tool. This is again a tool to potentially deploy your service in an energy-efficient infrastructure. And finally, the energy-aware service operation tool, how to ensure that your service again operates in a most energy-efficient infrastructure or cloud infrastructure. So there is basically a clear mapping between these tools and the actual layers. So you can expect that the stakeholders that we've mentioned earlier, as well as the actors, could actually benefit from the entire toolbox or a subset of those of the tools, in order again to operate their services in a cloud environment. So basically, on the left-hand side of the slide, you can actually see the cloud, the reference cloud architecture that ASCETiC has proposed. On the top of the first layer being the SaaS SDK, with again components to support energy awareness, very much tailored towards requirements engineering and the programming model. The PAS tools is again very much to do with how you manage your application in an energy efficient environment. And finally, the IS layer, where the IS tools actually reside, where you could expect here to operate your service in the most energy efficient infrastructure. Worth mentioning here that in the past you had the self-adaptation manager, which is a subcomponent of the application manager, and on the IS you had the self-adaptation manager, which is part of the virtual machine manager. And what's interesting about these components is that they could support self-adaptation at the intra-layer, very much where they can work with other components in the same layer to, again, support energy efficiency. And at the same time, these components contribute to what we call the inter-layer self-adaptation, where the layers in this cloud reference architecture can actually cooperate and work together in order to support energy efficiency. Another aspect of this is that there are various ways where you could deploy and adopt the reference architecture. The basic example is to say all these three layers could actually belong to the same entity. You take the example of Amazon or Google or Microsoft or whatever cloud provider that could potentially be interested in cloud construction, deployment, and operation at once. You could take another adoption where you have the PaaS and the IS belonging to the same provider, and then the SaaS belonging to a potential stakeholder or actor. You could take potentially the three layers belonging to three different entities, to three different entities, but again, expecting that this would you expect that these layers and the components with this layer could actually talk to each other. So there are again various paths where you could adopt this architecture, and we have a deliverable that explains this adoption path in more detail. So what are basically the main innovations in this by taking a reference architecture and implementing it? Well, we can basically look at the programming model at the SaaS SDK and say, well, this programming model can actually support scheduling policies at application level to optimize performance, energy, and cost. And the programming model is based on the COMPS programming model from Barcelona Supercomputing Center. We look at the requirements and design modeling plugin. This is again to look at how you could specify generic SAS goals and requirements and learn about the actual requirements patterns from the time again you design your software. It has an intuitive interface to identify the deployment configuration to achieve quantitative requirements on performance, energy, and cost as well. So that's going to be very handy, again, as a tool for software engineers. It has a code optimizer, which basically main role is to identify hotspots at code level and analyze your programs before you actually deploy them. So this is a very handy tool that could potentially tell you that it is likely that you're going to consume less or more energy just by tweaking your code. At the SaaS level, we have a self-adaptation manager, which, as mentioned earlier, is very much a decision engine to decide on the type of adaptation to make at the PaaS level. We have an energy modeler, which is again to look at how much energy an application is likely to consume on specific infrastructure and their optimization policies. We can look at the VM contextualizer, which is an infrastructure agnostic contextualization tool. So it allows you the automatic configuration of your service in terms, for example, of libraries and before it is deployed on a cloud environment. And it supports interoperability between IaaS providers because because of the recontextualization mechanisms that are currently implemented. So you can actually take a service running on infrastructure X and potentially redeploy it on infrastructure Y on the fly, and thanks to an automatic recontextualization of the service. The pricing modeler is to do with energy-aware pricing per application and application events. The SLA manager is an important component in this framework because of the negotiation of the actual service and service requirements in terms of SLA terms to support energy performance and cost. So you will expect this component also to have the same role at the IS level. So at the IS, we have the VM manager, which looks at the managing the virtual machine at service operation. And it also supports self-adaptation management, scheduling, and management policies. So this is the core of the self-adaptation is supported by this component. And as mentioned earlier, you could see adaptation at both levels, intra-layer between the components within the same layer, or inter-layer, where the IS, for example, would need to adapt in a coherent way with the pass layer. The energy modeler supports physical resources providing. That's also come handy when it comes to power-aware scheduling and management, and it will also support a watt meter emulator, just in case watt meters are not available in a cloud infrastructure. This emulator basically would replace that. So it has an interesting algorithm that looks at how, thanks to monitor data, you can calibrate the data and emulate any watt meter. The infrastructure monitor is to do with, of course, how you monitor your application running on a cloud infrastructure. It enhances the scalability and applicability of the ASCETiC toolbox, and it's at the moment it's based on the Zabbix monitoring tool, and also provides the support for the installation of monitoring probes through libvirt. The pricing modeler at the IS level has the role to handle time-varying energy costs faced by IS providers, as advertised by energy providers, and also support novel tariffs which incorporate explicit energy consumption charges. Finally, as mentioned earlier, the SLA manager is very much supports the SLA negotiation with the pass layer. So, this is very much what I had to say about ASCETiC approach in terms of proposing a reference architecture and its implementation. I'm more than happy to answer any of your questions at the end of this presentation. I'm going to hand over to Anna.
Yes, I share now my screen. Share program. And I will continue with the business aspect for the ASCETiC project. I start with the business goals. While developing our toolbox, we defined a set of business goals that has helped us to drive all our work. The first of them, it is the ambition of providing a greener ICT in order to support the European organizations to achieve ICT decarbonization process. Also, to provide means for ecological and economical sustainable ecosystem, and where both the SLA and the pricing schemes aim to provide the right balance between economy and ecology. To support the organizations in addressing the efforts to be more socially responsible corporate citizens, while at the same time optimize the cost of operation. and also to make the consideration of transparency for the customer in all decisions basically that affect cost. And this means the consideration of energy metrics for the SLA and monitoring, but also to provide the user with tools to have visibility on the provider's resource consumption and the optimization applied policies. Also in our toolbox, we have ambition to make use of de facto and market standards, so to support interoperability of our tools with other cloud stacks, but also to facilitate the adoption of our project results. And overall, we wanted to support cloud providers' pursuit of cost and energy reduction, and a clear need that they are facing today. We wanted to provide a solution for cloud providers so they could assess and determine and in fact optimize the relation of gain value per each unit of energy spent. And not to forget, we are considering in ASCETiC, our tools consider both server-side computing and storage optimization consumption, and this is for covering as much variety of cloud workloads as possible. So based on these business goals, we have here in this slide our ASCETiC value chain. This value chain presents the main stakeholders involved in the ASCETiC solution. As in any cloud offering, our value chain considers hardware providers, virtualization vendors, and energy providers as necessary building blocks for our offering, but also in this group we have energy meters providers that, as Karin was introducing before, are in fact an optional actor in our value chain, given that in the project we have considered alternative means to monitor energy, such as the use of simulations and other tools that take advantage of service energy monitoring capabilities such as EPMI. But as we have been presenting all the time, the core of our stakeholders are the cloud providers, both infrastructure, platform and software as a service cloud providers. For each of them, in the coming slides, we analyze their value proposition and we remark which are the advantages that we foresee for our solution. So we're starting with the software as a service. As Karin has introduced, our software as a service layer provides capabilities for energy-aware application and service constructions, and essentially we offer two methodologies. The first one starts with the software requirements phase, where we provide tools to map user KPIs to energy measurements and quality measurements. And the second approach leverages on our programming model, that it has a runtime, that it is able to obtain the energy measurements for the different parts of the application or the service. In addition, the construction capabilities also consider the creation of application packages and virtual images to be deployed in the cloud, and it offers the capability of analyzing the source code to detect hotspots and analyze the energy spent by components by profiling it. So we understand that our SaaS tools offer four key values. One, it is the infrastructure independence, also the capability to do energy modeling at application component level, the capability to define and model KPIs, and the ability to self-adapt. As for all of our tools, there exist in the market other solutions or parts of these solutions that cover parts of the features that we offer in ASCETiC. However, specifically for our SAS tools, they nowadays do not take into account energy-related aspects, and they do not include KPI specifications as defined by the user. We understand that SaaS providers and in general software developers can benefit of ASCETiC adoption as a way to improve their energy consumption behavior. At the level of platform as a service, our platform as a service toolset or tools are able to manage the life cycle of an application that it is ASCETiC compliant. Generally speaking, it reads the requirements of the application and selects the best infrastructure provider in which to deploy it, and during execution the SLA manager monitors that the SLA is fulfilled, and if something is violated, it notifies the self-adaptation manager in order to take decisions. These decisions can be actions in order to change the provider or to adapt the provider, taking into account pricing and energy predictions. Existing solutions in the market, and there exist a lot of solutions that take care of the performance and the automation that we are offering, but currently they do not include considerations of energy awareness, and they do not optimize on energy-based aspects, and they do neither consider automatic and two-way negotiation of SLAs as we are doing in ASCETiC. And finally, in the IaaS level, our toolsets are able to manage the life cycle of the virtual machines that contain the services and the applications to be run. The virtual machines are allocated and managed in order to maximize the achievements of SLAs from a provider perspective, and the overall objective is to maximize the energy usage by performing multi-objective optimization processes. The key values that we have for our infrastructure as a service solution, it is the fact that it is agnostic from both cloud middleware and monitoring solutions. It offers capabilities for energy modeling, and it offers PM deployment optimization using different schedulers to optimize energy. In our view, infrastructure as a service providers can benefit of ASCETiC adoption as a way to cut cost and increase margins, and overall as an improvement of their public image as having a more energy efficient and ecologically behavior. During the ASCETiC project, we have developed a set of business models, and they are basically focusing on cloud providers and with the consideration of additional key stakeholders such as the energy providers. The business models in the project consider standalone business models for IaaS, PaaS and SaaS providers, as well as combinational business models for different offerings, as we find in the cloud market today, and with and without the consideration of the energy providers to be involved. And just to close this part, as I was introducing when we started this webinar, it is an introductory presentation for our ASCETiC project developments, considering the context of the project and also the architecture. And this is followed by more technical webinars focusing on the different specific tools that we have developed during this week and later in this month. In these webinars, we will be focusing on the installation and usage for both IaaS, PaaS and SaaS tools, And in addition, if you would like to have more information about our project, you can visit the ASCETICproject.eu website, where we have information more scientific and related to our research project developments, and the ASCETIC.eu website, where you find information specific for our tools. Also, you can see and download our code from GitHub, and you can follow our news in our Twitter account. So just to thank you all for your attention, and now we open the floor to any question or any comment you would like to make to what you have seen in this presentation.
Thank you.
So do we have any question for the presentation right now with the people attending? I understand this is a no, so just from our side to thank you all a lot for attending this webinar, and also the presenters for the work for preparing it, and this webinar will be recorded and available through the project website in the coming days. Thank you very much all.
Thanks a lot.
Thanks. Thank you.